protractor with the notes that we're going to take. All right, so just to refresh your memory a little bit, you guys, when you're looking at a protractor, sorry, it's shaking a lot. When you're looking at a protractor, you have a couple things you're going to keep in mind. There's like a straight edge at the bottom. There's also a ruler, inch ruler, and centimeters, which we can use for today. And down below here, for my protractor, I have a hole. For some people, you guys might have just like a dot there, but that's supposed to line up with the vertex. So if I'm measuring an angle, that's supposed to, I should be able to see the vertex through it. So if P is my point of rotation and that's my vertex, I should have the hole, or the point being visible through the hole. Okay, the other thing is that this line that you guys see through the hole, that cuts through the hole right here, like that line, that should be one of the sides of your angles. This should be one of the sides of your angles. Okay, so then if you're lining it up, just make sure you have one of the edges of the angles lined up to that. Thank you, Andrew. It's page 6, yes. Okay, so we're gonna start with, this is direct, we're not gonna do the full thing. I just wanted to show you guys. I normally use patty paper, but patty paper is something I usually hand out in class to you guys, and I didn't want you to go buy patty paper if you don't know what patty paper is. It's, does anyone know what it is? It's the sheet of paper that you guys would put between hamburger patties. And you could buy them like 1,000 a pack, which I usually have, but I give it out to you guys. So we're going to try the protractor way instead, and hopefully it gives you guys that visual. All right, so we're going to start with trying to rotate point L. Okay, so every transformation that we've done so far, the translation, the reflection, those two are called rigid transformations as well as rotation. And a rigid transformation simply means that you maintain congruence. So the shape stays the same, the size stays the same of whatever segment or side that you guys are rotating. Oh, okay. Yeah, so it's okay. Do you have this image here, Gavin? Do you have that image?
Is it LOMN?
Yeah. Do you have that image on there?
Yeah, I do.
Okay, that's all you need. It's going to look a little bit different. So what you're going to do, if we want to rotate L, and let's say it says 110 degrees. Okay, so we're going to use our protractor to do that. We have to first connect. The first step is to connect. The point of rotation is P. So we're going to rotate L about P 110 degrees. So go ahead and connect L to P. Okay, you guys can do a dotted line. Okay, so the length of that segment is important because when we rotate that, we're going to rotate not only the angle measure, but then keep the length of that segment as well. So what we'll do is first, let's mark off 110 degrees. Again, the hole should go through P. So you guys should see P through as the vertex. And then right now, this is wrong where I have my, this edge because it's not lined up with one side of the angle. And one side of the angle is that pink line I drew. So what I'm going to do is rotate it just a bit so that it lies, so the hole goes through P, and then that line is going over L. Okay, and then 110 degrees, if this was one side of my angle, then 110 degrees is going to be bigger. It's an obtuse angle, so it's going to be bigger than 90 degrees. So instead of going 110 degrees like that, that's an acute angle. That doesn't make sense. So I'm going to use this 110 degrees, which then would make an obtuse angle with this side. Okay, so 110 degrees is all the way up here for me. So I'm just going to do a little marker to indicate the direction. Okay, and I don't want to draw the entire segment because, the entire segment from that all the way to P because that's too long. I need to just draw the length of this going in that angle direction. Okay, so now use, let me see if centimeters works better. Use your ruler portion of your protractor, or if you guys don't have that, you can use your actual ruler itself. So it looks like it's 1.5 centimeters is what mine says. So what I'm going to do is measure it out in this direction and measure out 1.5 centimeters. So make sure your ruler is lined up to P and to the marker for the angle up here. And you guys are gonna do a centimeter and a half. So that's 1 centimeter right here, and then a half is about right here. Okay, mark off that point. And this time you guys are gonna connect P to now what is L prime. Okay, so this is my L prime. Okay, so that satisfies the 110-degree rotation of L. So angle, mark off the angle, and then measure out the segment length, and then you have your rotation. So that's without graph paper, with the protractor. Now what I want you guys to do, if you have different colors, it would help for you for notes today too. I'm going to do in a different color. Let's rotate M. Okay, so let's say that I wanted to do a 110-degree rotation of M. So the first step is connect P to M. So remember, that's your first step, is connect from the point of rotation, the original point. So let's say you wanted to do 110 degrees of M, which then means you connect P to M. And now again, line up the hole with P. Make sure that you guys rotate your protractor so that the edge lines up with M, like that. Okay, so this is not good. This is better for the vertex, and then this is best. Now, when you have this line over P and M. Okay, then from there we're going to mark 110 degrees from there. So then we want 110 degrees from here, obtuse angle, which means it's somewhere up here. So right here, I'm going to mark it off. Then I'm going to measure the length of that segment that I'm trying to rotate. So let's say you measure it, it's the same length, 1.5 centimeters. We're gonna go back to my angle measure. Okay, so P to now my new M, and then mark off 1.5 inches in that direction. Okay, so this is a centimeter, oh sorry, it's 1.5 centimeters. So let me use this part of it. You don't have to start right at 1, right? You can just start at, like for me, 7, that's 1 centimeter. 1/2 is right here. And then now connect P to your new M prime. And you guys can see that that's 110-degree rotation. It's a little bit slightly more than 90 degrees. So now L prime M prime represents the 90-degree or 110-degree rotation of, and let me highlight that segment so you guys can see. So LM was this, and now L prime M prime is this. So if I were to rotate LM, the segment LM, to L prime M prime 110 degrees, that's what I would get. So if you were to complete all of that using the protractor, you guys can see that's the same image that we have right here for the finished product. Okay, so this is LM, and then it got rotated 110 degrees to L prime M prime. And we can do that with the other 2 coordinate points connected together and see that the rotation maintains the same shape and size. So it would, and Kelly, if you keep, I will record this session and have it posted if your internet is like not working for you. So we're not going to do this because I wanted to show you guys my method of rotation. So on the, actually on the next page, I'm going to switch to Notability now. And it's a little bit easier for us to see that way. Let me see. All right, on Notability, or sorry, on your notes, we're going to be now on page 7 of the notes. And I'll be honest with you guys, I don't like teaching the rules of rotations just because, and that might be the way that you guys learned it initially, but I like seeing the visual of it first. So every time I do rotations, I don't follow the rules. I just, well, follow the rules as in like follow the rules, memorize the rules and then follow it that way. What I do is I like to get a visual of it. So I'm going to start you guys off. We're not going to do every single point on here, but I'm going to start you guys off with like, how do I go about doing the rotation in either counterclockwise or clockwise. So first, actually on the very top, can you guys draw your XY axis? Okay, so in geometry, algebra 2 trig, beyond, we call a positive rotation a counterclockwise rotation. So can you guys write default is counterclockwise, meaning that if the textbook or if the worksheet does not say rotate it clockwise or rotate it counterclockwise, you are going to assume that they mean counterclockwise. That's the positive direction. Okay, and so the best way for you guys to think of it is like, okay, this is quadrant 1. Where do I go after quadrant 1 for quadrant 2? That's over here. That's in a counterclockwise direction. So counterclockwise means you go against what the rotation normally is for a clock. And that's eventually algebra 2 trig for the trig portion, a unit circle. That's how we do rotations as well. A positive rotation is a counterclockwise direction. Okay, so if we say a 90-degree rotation, what happens is that you have a point, if it's here, a 90-degree rotation counterclockwise is going to put you here. And then 180 is going to put you here. What degrees is this one, you guys? So if you did, you have an original point here, then you went here, here, and then here. How many degrees? Good, that's 270 degrees. For the 270 degrees one, if it helps you guys to think of it that instead of like 90, 180, 270, you can also think the opposite direction is 90 degrees, but clockwise. So a 270 degree rotation counterclockwise is equivalent to a 90 degrees clockwise. Okay, and so that helps sometimes instead of doing the rotation multiple times. All right, so let's begin with that point 47. Can I have you guys all plot 47? So I picked one that was in the first quadrant, and I'm going to label it P. You don't have to label all the coordinate points. And what I'm going to suggest you guys do, if you do any type of 90-degree rotation, you're going to switch the X and Y. And the reason for that is that if you think of two lines that are perpendicular, don't draw this out, two lines that are perpendicular. From Algebra 1, do you guys remember what the relationship is for slope of two lines that are perpendicular? What's the relationship between the slopes of two lines that are perpendicular? Anyone have any recollection of that? Two lines that are perpendicular.
Y equals X.
Sorry, Gavin, I didn't hear you. What did you say? You say that again?
Y equals 1x.
Okay, yeah, so that you're getting to the slope being 1. But if you had a slope, let's say of 1, then the slope perpendicular would be the opposite reciprocal of that, -1. Yeah, so it's opposite reciprocal. So in order for us to like apply that concept here, when I rotate, let's say P, and this one doesn't, for this problem, it doesn't mention anything about clockwise or counterclockwise, so I'm going to assume counterclockwise. Okay, so because it says 270 degrees counterclockwise, okay, if P is in quadrant 1 and I'm doing counterclockwise, this is 90 degrees over here, 180, 270 would be here, which is the same thing as a 90 degree rotation in this direction. So instead of going 270 all the way around, I'm going to go 90 degrees clockwise. So I'm going to mention that here. It's the same thing as 90 degrees clockwise. Okay, so the important thing is figure out what quadrant you're in. And now go ahead and interchange X and Y. So the coordinate point was 4, 7. Interchanging means that you're going to switch X and Y so you get 7, 4. And plot 7, 4 in that quadrant. So you're going to think, okay, well, 7 is here. 4 is negative in this quadrant, though. And so what you're going to do is when you assign the point, it's now 7, -4. So this is P prime. So figure out the signs afterwards. What I do is I just switch the X and Y, don't pay attention to any of the negatives, and then figure out, well, in quadrant 4, we have a positive X and a negative Y. And just make sure that makes sense with the coordinate point that you have. When you check your work, this is what's supposed to happen. You don't have to draw this out, but when I connect, the point of rotation is the origin. So if I connect this, I see that I form a 90-degree angle. Okay, so when you're checking your work, make sure it makes sense. So let's try the next point, and it just really takes practice as you're doing this. I'm going to switch colors and do S next. Okay, so 1, -1 is 1, -1 here. And can I have you guys practice by We're going to call that S. Remember, 270 degrees counter is the same thing as 90-degree clockwise. In the chat, if you guys want to do private, that's fine too. Can you tell me what quadrant will you guys end up in if you rotate S 90 degrees clockwise? What quadrant will you end up in? Okay, perfect. You're going to end up in the third quadrant. So if I don't pay any mind to the fact that you have signs for 1 and -1, if I put it in the third quadrant, 1, -1, or just 1, 1 as the points, I'm going to end up here. And so when you're assigning S primes coordinate points in the quadrant, in third quadrant, X and Y is negative. So it's -1, -1. And if I were to draw segments to the origin, you can see you formed a 90-degree angle. Okay, so then that's S prime. So far I have P prime, S prime. And then now I'd like you guys to tell me what coordinate it is. If you guys were to rotate, and I'll switch colors to something else because that's too similar. Okay, let's do R now. Okay, go ahead and plot R. Okay, so same quadrant. Yeah, so you're going to switch X and Y, which then means it's 2, 3. And then you're going to plot it in the third quadrant. So I'm going to erase this. And type it into the chat. What do you guys think that coordinate point is when you guys finish it? Ava, that's correct. Okay, and pay mind to the fact that you guys are in the third quadrant where X is negative and Y is negative as well. Okay, good. So some of you guys corrected yourselves. So this is now my R prime. Okay, so I have, and let me just make sure I erase this one because it was hard to, that was my S prime. Okay, now as the last coordinate point for Q, and the correct answer was -2, -3. Okay, so for Q, let's say you guys have for Q 6, 6. So this one's in the first quadrant. Type into the chat, what do you think a 90-degree rotation clockwise is going to lead you guys to? Okay, good, Phoebe. Good, Ava. Good, Gavin. Okay, Christian's fixing it. And ask yourself, you guys, what quadrant you're going to be in, right? You're going to be in the fourth quadrant where when you were assigning the values, switching it means that it's now going to be 6, +6, -6 in that quadrant, Q prime. And if we were to build the shape from it, we're going to connect P prime to Q prime. We're going to connect S prime to R prime, and then make what they describe as a parallelogram. So that's the shape rotated. Okay, 90 degrees clockwise or 270 degrees counterclockwise. 11:42, and we have, okay. So what I'm going to do next is just same thing. I want everyone to participate as much as possible in the chat, and you can do it privately if you guys have to. I want to make sure you guys understand the 180-degree rotation next. Okay, and I'm going to do that by breaking it down into the rotations as 90 degrees. So first, let's say you guys plotted A as -3, 5. Okay, and let's say -3, 5, that's A. If I were to rotate it 180 degrees, that would mean that the A, if you can all look up from your paper after you plot A, 180 degrees would be 2 90-degree rotations. So if you went in this direction, counter or clockwise, and then another 90 degrees would put you in this quadrant. does it matter? Yes or no, you guys? Does it matter which direction you guys go in? If it's 180 degrees, does it matter clockwise or counterclockwise? No, right? We're gonna end up in the third quadrant regardless. So if I think of 180 degrees as two 90-degree rotations, let's practice just the 90-degree rotation of A. Okay, it doesn't matter what direction. So let's go ahead and go clockwise. If you guys put A in the first quadrant, what's your coordinate point in that one? So what's the new coordinate point?
5, 3.
Okay, perfect. 5, 3. I can see I make a 90-degree here. So that's 90 degrees. And then now take that point and then do another 90-degree rotation and see what you guys get. Remember, switch X and Y when you're doing 90-degree rotation, and then assign the appropriate positive or negative depending on the quadrant that you're in. So what is the new coordinate point? What is A prime? Okay, good. And if 3, negative 5, very nice, you guys. So if it meant that if I use the rules that I was just going over with you guys and I switched X and Y, then I switched again, we see that the interchanging doesn't have to happen for an 180-degree rotation. But what you'll notice is that the signs are opposite for each one. So X is now positive, and then Y that was positive is now negative. Okay, so using a rule or applying a rule would be something that some of you guys might be interested in. So negative 3, 5. So can you guys, now using the rule, tell me what B would be? Or sorry, what B prime would be? Yes, so no need to interchange, good. So B prime would be 0, negative 2. And then what would, good. So what would C be, you guys? Or C prime? Okay, good. 5, negative 1. And then if you plot A prime, B prime, C prime, now you have a 180-degree rotation of A, B, C, of triangle A, B, C. Very nice. The last thing I'm going to do with you guys is summarize the rules, because some students do like to use the rules instead, and we'll use the notation on, you guys are my 5th period, so tomorrow I'll go over the notation, but we'll just do words for now. So 90 degrees is you multiply, when they say multiply, they mean just when you multiply a positive number by negative 1, you get a negative number. So multiply the y coordinate by negative 1. And as I'm writing this, I'll just tell you guys that I don't memorize these rules. I just use what I did with you guys as the way to understand rotations for 2 reasons. It makes sense visually, and I'm not just applying a rule blindly, not understanding where it comes from. Visually, it makes sense to me, and I like for you guys to do it that way as well, just because I hate for you to apply the wrong rule. That's the problem, is like if we don't understand it conceptually, that's sometimes what happens on the test. Okay, so here it says multiply the y coordinate by negative 1, which means make it the opposite, and then interchange the x and y coordinates. 180 degrees, we saw that we didn't have to interchange. We just had to make the x and y coordinates opposite. So another way of saying that is multiply the x and y coordinate by negative 1. And the last rule for the 270 degrees is instead of multiplying the y coordinate, we're going to multiply the x coordinate by negative 1 and interchange as well. once again, if you don't have to memorize these rules, you guys can just use what we did below if that helps you guys. As the, let's see how much time I have with you guys. Yeah, as one last check, just to make sure this makes sense to you guys. Can you guys tell me when it says for number 1, 90 degrees without any direction, specific rotation? Can you guys tell me, is it clockwise or is it counterclockwise? Can you type it into the chat? Is 90 degrees there clockwise or counter? Okay, so on your homework, if it doesn't say clockwise or counter, you're gonna assume counter. Good. Let's pick one coordinate point and let me just make sure you guys can do it. Okay, so -6, -2. We're gonna do 90 degrees counterclockwise. So go ahead and plot that -6, -2. That's n. We're gonna do a counterclockwise. And can you guys type it in the private chat? What's your new n prime? Your pre-image is n. Your image is your n prime. Okay, you're doing a counterclockwise. Okay, so we know for 90 degrees, any direction, we switch x and y. We go in a counter direction, which is in this direction. So 2 and 6. But in this quadrant, 2, 6 is really 2 comma -6. Good, that's n prime. Oh, okay. So very nice. All right, you guys. So I'm going to stop and just ask you guys a